Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, December 2nd. Looking at significant wave heights for the North Pacific Ocean, we see a decent pattern in play. Hard to believe. Here's a storm just west of the dateline, 50-foot seas aimed to the east, and another system, a gale, cut-off gale actually, producing 23-foot seas aimed south, somewhat at Hawaii, somewhat at the U.S. West Coast. But it is this system over in the Western Pacific that is of most interest. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for trough. That is a dip in the jet, like right here. And that, of course, helps to create a counterclockwise flow aloft and down at the surface. And, of course, counterclockwise flow in the northern hemisphere is a sign of low pressure. Really, it is the sign of low pressure. Of course, low pressure, if it's strong enough and deep enough, generates winds. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. So, we have what appears to be a rather modest-looking trough here, with only, what is that, maybe 110 knot winds flowing into it, 140 knot winds down at the bottom. But we know for a fact there's a storm here with good, strong winds and generating large seas, so the trough is a bit deceiving. We also see east of there, a bit of a split jet thing going on right over in this area, not supportive of gale development. And then you see the jet consolidate right here over California, pretty much moving out, supporting low pressure inland from the U.S., but this is what was generating wind and rain and all the weather into California a few days ago. All right, moving forward, we see the trough continue getting quite pronounced into Monday over the North Dateline region, and also it almost appears like some sort of a cutoff trough trying to develop off California as we get into Monday. It really is split, and typically you'd see high pressure here, but when you get a trough inside of the split pattern, sometimes you can get low pressure as well, and that is the expected result you see there as we get into Tuesday morning. Very well pronounced trough, not a lot of wind supporting it, while at the same time the trough on the dateline as we get into about Tuesday morning starts fading out. We continue on, the trough continues off California as we get into Tuesday night, and then notice the trough almost here in the it's now in the northwestern Gulf of Alaska, tries to redevelop Wednesday. Winds building into it at 140 knots. Also notice a pretty consolidated jet starting to build off Japan as we get into Wednesday. Roll this out some more. Look at this trough just sits here, does not move as we get into Wednesday night. Finally, Thursday starts moving onshore, but also notice this. This is a split jet, but most of the energy is in the north. It looks like it's starting to carve out a trough right in here. That would be supportive of gale development. And there you go. Nice little trough as we get into Friday. That suggests yet more gale development. And look at this. More wind energy building back by Japan. This is actually a pretty impressive storm pattern here. And you just see the jet, boom, just going like this, ridging over the dateline, falling into the Gulf, splitting, but a lot of energy coming into California at the same time. And we'll just take this out a little bit further. Look at that. That is a pretty nice looking trough. Look at, almost 190 knot winds building off Japan as we get into Saturday. And then you get the sense this trough just wants to come blasting onshore as we get into Sunday into California. Look at that. That is a very consolidated, very solid jet. Pretty interesting looking pattern. Gale development would be confined to Kamchatka there, or the Gulf of Alaska at 180 hours out. So the short of it is, looks like storm development, if anything, is going to be improving with a building jet and a bit of activity in the Gulf of Alaska and more weather for California. Not a bad pattern. So let's take a look down at the surface, see what's going on. Now remember that trough that was here, pretty just innocuous looking, but amazingly here we have 55 to 60 knot winds, and even 12 hours ago it was up to 60 knot winds, 60 to 65 knot hurricane force over the dateline. That's how you get 50-foot seas or bigger. Anyway, good, nice, solid storm here. Here's that cut-off low we were talking about. Not really doing a lot, but we'll just sort of keep our eye on it. There you go. You see a little bit of fetch as we get into Sunday night, pushing south, but not really aimed anywhere. You know, this guy is the main focus of activity. Roll this out. Now notice the storm starts lifting north as we get into Monday, midday Monday, still 55 knot winds, and continues, finally fades out like Monday night with 45, 40 knot winds. Normally we'd go, oh, that looks very solid, just like that. And that's like the fading remnants of what was a much stronger storm. Also, low pressure. Actually, we'll roll this back. This is sort of the remnants of this cutoff low. It starts moving up to California on Tuesday. We not so much a swell producer as perhaps yet more rain and, or if nothing else, south winds along the central and north California coast. You can see it there. And it starts moving inland and falling south as we get into Wednesday night. We're sort of not looking back here because there's not a whole lot going on. This low moves basically onshore over Southern California later Thursday. And now we know the jet is starting to wake up. A bit of a trough is expected over here, something over here. Let's see what happens. There you go. Nice little blast of 40 to 45 knot winds on Friday. Aim southeast, certainly good for some swell into Hawaii and the U.S. West Coast. And that continues pushing east into Friday night. Another gale storm develops over the Kuril Islands, 50 knot winds. So there we go. Oh, 45 knot winds off the U.S. West Coast on Saturday. And actually, maybe not too much wind in California, if you would believe that. This is, and building to 50 knots over a tiny fetch as we get into Saturday night. Continuing, you see the front starting to rake the coast there as we get into Sunday. Interesting, broad area fetch. Certainly, this is a very productive pattern, to say the least. So we'll just have to see what happens, but no shortage of storm activity. We basically went from nothing to now everything's just going off the charts. Some of this aided by the active phase of the MJO, but even that's fading out now. So just a very active storm pattern indeed. All right, a quick look back. We're back Saturday night. The storm started developing off Japan, building. There we go, 41-foot seas in 6 hours to Sunday morning. 50-foot seas right there to now with 51-foot seas. Nice solid pattern. And then here's the forecast moving forward. And we just checked, there have been no good JSON-2 satellite passes over the storm so far. So here we are, 18Z Sunday, moving to Sunday night. That'd be about 4 p.m. California time. Seas 48 feet modeled, 48.8 at 40 north and just west of the date line, 177.5 east. You see it. Now the system is to regroup on Monday. There you go, with, what is that, 53-foot seas, building to 55-foot seas. Now, aimed a bit, drifting north, aimed well to the east, not so much energy pushing at Hawaii, more at the U.S. West Coast, but from a more northerly angle and from a good distance away, then fading 50 feet Monday night to 44 feet. You kind of get the picture here, and fading out as we get into Tuesday night. Still, a broad area of seas, a lot of energy pushing east and towards Hawaii. In fact, you can see the very leading edge of the swell, Ross seas pushing into Kauai by Tuesday night. And there you go into Wednesday, swamping the islands, and the energy also pushing towards California. You just see it for yourself there. Let's see, anything else? There we go. Here comes our new fetch in the Western Gulf on Friday, with seas building from 23 feet to 26 or 27 feet to 30 feet. As we get into Saturday morning, 30-foot seas, about 1,200 miles off the California coast, and sitting there and spinning. That's a lot. I mean, this is just basically nonstop swell pushing towards the U.S. West Coast. I think the bigger issue is not going to be so much swell, but weather. Find your protected spots probably is the best option. And there we're at 180 hours out. More than likely, more to develop behind this one. So nonstop swell, basically, is the forecast. I guess we can't complain. All right, so then let's take a quick glance at wind pattern. Winds, not horrible as the sunset along the North California coast. Finally, it had backed off. It was almost calm at sunset. Sort of still a northeast wind pattern into the Hawaiian Islands. Roll this out into Monday. Southeast winds start building along California. Here comes the next low, building as we start switching to trades for the Hawaiian Islands. Get into Tuesday, south winds in control from Point Conception northward, Southern California protected, and pretty brisk trades into the Hawaiian Islands. So we get into Wednesday, here comes the south winds into Southern California. The low starts sinking south. Trade still into the Hawaiian Islands through Wednesday, and then maybe Wednesday night start turning towards an offshore flow for, we'll say, Monterey Bay northward. So we get into Thursday, wind starts slacking off for the Hawaiian Islands, turn into a light flow from, let's say, Monterey Bay northward, and then it sort of looks like inclement weather moving towards Hawaii as we get into Friday. Friday, light winds for all the California coast. And as we get into Saturday, still the case. In fact, almost dead winds, front just off the coast. Northeast winds blowing briskly into the Hawaiian Islands. And maybe okay into Saturday for for Central California, we'll say. But then by Sunday, it looks like a good solid front starts setting up off the coast. And the south wind machine kicks in. Still kind of east-northeast trades, not even trades. I'd say, just east-northeast winds for the Hawaiian Islands. On Sunday, kind of a mess for Northern California till we get into, whoops, we didn't get to Monday. So Sunday night's it. This low probably pushes onshore. Let's go take a look at precip for California and specifically snow. So a bit of a dry out today on Sunday. No, a couple little snow showers at best, maybe projected. And then Monday, nothing, and all the way through the day until you get to about 10 o'clock at night, and then the rain starts in the Bay Area and points north of the Ware down into Monterey Bay. Light snow for Tahoe and the Sierra during the day Tuesday. Nothing significant. This is really, this is a kind of a cutoff low. Yes, the jet's sort of, but remember the jet's doing sort of this split pattern, and it's a trough embedded in that split flow. So it doesn't have a lot of energy. Light snow into Tahoe and the Sierra continues into Wednesday. Light rain along the coast. More of the same as you get into Thursday. Finally, things stop for Tahoe, Southern Sierra, light snow. Southern California, though, getting some rain, and that's not a bad thing, and that continues into, it just goes on into almost Friday before things finally dry out. Then let's see, where is our next batch of rain? You see the front building off the coast as we get through Saturday. And Sunday, it looks like, yes, at least into, let's say, from San Francisco northward, then the rain starts, certainly as we get into Monday. Oops, and that's the end of it. So you kind of get the picture. Still precipitation, though not particularly heavy. Maybe a bit of a, sort of off and on wind and then not so bad. But find the holes in the storms. That's when you're going to get probably the best odds for surf, at least with good conditions. Quick look at the snow dashboard, Squaw Valley. Not a whole lot of precip. As this is 10 days out, maybe 16 inches or so. Snow levels, you see the issue here. Low. So remember the chart. This is the bottom at Squaw Valley. This is the base. This is the top. The blue is good freezing temperatures. White is freezing, but where you have the gray, that's borderline like snow flurries, sort of slush sort of thing. So right now, good snow level, but then the snow level, the non-freezing temperatures start rising, and we have almost a week there of not particularly favorable situation for snow production. Then snow levels start falling again, and you see accordingly snowfall amounts start building. Wind, yes, wind building as we get into the lowering snow level again. What change of the weather pattern, we know why that, because there's going to be a massive low-pressure system just off the coast as we get into the end of the model run here. Mammoth, very much the same situation. Foot of snow, but that's not till, a week out. Mostly, we'll say 6 inches in somewhere the December 4th time frame sort of thing. Same picture at the upper level. Where is it? The bottom of the mountain is here, the top of the mountain up here. So snow level's better because, of course, Mammoth is considerably higher. The base is somewhere around 8,000 feet, and so that's a lot different than Squaw, which is down about 6,200, something like that. Wind situation, very much the same. All the same weather patterns affecting these resorts the same way. Long term, let's go take a look. What's going on with the MJO and, of course, the supposed El Nino Southern Oscillation. As usual, we like to look at winds in what we call the Kelvin wave generation area, basically the western Pacific on the equator. When you have so this is New Guinea, this is the equator here, this is the far east Pacific, this is the far west Pacific. When you have westerly winds in the area from 135 east to 170 west, 5 degrees north and south of the equator, just like you see right there and there and there, that's indicative of the active phase of the MJO. And that is what, when you have west winds in this area, that feeds energy into the jet stream. That also can produce Kelvin waves down at the ocean surface, which in turn, that's basically warm water pushing to the east. That can help fuel El Nino. And so you see we have trades over the entire Pacific, which is pretty normal, till you get to about the date line, and then it turns to west winds. Let's look at anomalies, differences from normal for this time of year. It actually tells you even a more optimistic pattern. West winds can control the whole Kelvin wave generation area to, oh, look at this. Just about the whole way across the Pacific, some degree of westerly anomalies. That's actually pretty good. And that feeds the jet stream in general. It helps feed precipitation into California. This is the last bits of what was the active phase of the MJO pushing off to the east. About a week from now, the expectation is this will all change, and we also expect with that the precipitation potential will change into California. Now remember, the MJO, in the active phase, it moves from west to east, and it takes 4 weeks to make it from, let's say, the West Pacific to the East Pacific. So the active phase at this point is already all but gone, making it's out of the Kelvin wave generation area, moving over towards, if not completely across into the East Pacific, dragging westerly anomalies with it. But once the westerly anomalies fade, the expectation is that precipitation will fade with it. So this is probably the last little bit for a while. So let's take a look at what the wind anomalies, 850 millibar wind anomalies, that is differences from normal for this time of year in the wind. We only care about what's going on in the equator, and we only care about really what's going on in the Kelvin wave generation area. 170 west to 135 east. There's New Guinea there. There's South America. There's the Philippines, Mexico, you get it? So right here, you see westerly winds, basically the oranges and reds, that's the westerly winds. Just look at the anomalies. Look at the arrows. So you see westerly wind anomalies basically across the entire equator, and this was on November 26th, 27th. You just sort of go down, you eyeball it. If anything, it's even got more organized as we got into the 30th. So that's what's driving the storm track. That's what's driving the wind and the precipitation into California. All a very favorable pattern for the time being. And so we can sort of look at history too. 850 millibar zonal wind anomalies. So this is the date line right here, running right down the middle of the chart. This is the whole planet. There you go, 180 on a single chart. Kelvin wave generation area between these two tick marks. The Pacific is basically from this tick mark over to somewhere around here roughly. Okay, but anyway, the blues are easterly anomalies. The reds and yellows are westerly anomalies. This is time. So as you go down here, we'll just say starting around November 17th, you see westerly anomalies just completely filled the Kelvin wave generation area. There we go. There's your two tick marks we're looking at, right? And that was good. That's what started things off. Then here's where we are right now, and this is the GFS forecast down below. So this was attributable to the active phase of the MJO, and it moves from, you can look at it here, moves from west to east over time. So you can see it passing through the Pacific, heading off to the Atlantic. And then when it starts, so here's our big westerly anomalies from the, almost the middle of the Kelvin wave generation area, the whole way into the Galapagos Islands, let's say. But as we go down, each one of these tick marks is a day. You can see 3 days from now, the westerly anomalies are completely out of the Kelvin wave generation area. Weak easterly anomalies set in, so this suggests that the active phase of the MJO is moving out of the picture. The inactive phase is moving in, and when the inactive phase moves in, it tends to stomp on the jet stream, steal energy from it, and then the storm pattern sort of fades, and the rain and all that starts fading, unless you're in some sort of well-entrenched El Nino, which I would not say that we're in right now. So the expectation is, within a week or so, the rain pattern's probably going to let up. So let's go out 2 weeks. All right, so what are we looking at here? This is outgoing long-wave radiation. There's Australia. There's New Guinea, the Philippines. The equator runs right along here. There's South America, Mexico. You get it, okay? The blue is where the active phase of the MJO is. That is, blue is negative anomalies. That means less outgoing long-wave radiation is another way of saying sunlight reflectivity off the ocean surface. So if you have a lot of clouds, you don't have a lot of sun reflectivity off the ocean surface, and you get these negative anomalies. Assume this is the active phase of the MJO. So you can see the active phase of the MJO almost moving east past the date line now, out of the Kelvin wave generation area. Here's the inactive phase moving in. With that, you can just see the active phase disappearing. The inactive phase, this per the statistic model, moving into the Kelvin wave generation area. This is at a week out, this is 2 weeks out here. So that's when we say we think the precip thing into California and the storm track is going to weaken 2 weeks out. That's what we're basing it on. We go look at another model just to confirm. The GEFS model, it says basically the exact same thing. If anything, it shows the inactive phase a little bit stronger than the statistic model, but we'll split the difference. Either way, 2 weeks out, inactive phase sitting right in the middle of the Kelvin wave generation area. That would be, let's say, December 14th or so, something like that. So, and that's about what we had expected. Let's go keep digging a little deeper. Phase diagram charts, another way to examine the active phase of the MJO. So the actual active phase, so this is, assume you're looking down on the North Pole of our planet. The active and the inactive phase move from west to east, that is from the Indian Ocean, over the maritime continent, across the West Pacific, over the date line, into the East Pacific, across the Atlantic on the equator, then over into North Africa, and then back to the Indian Ocean. Heavy dot is where we'll call it the leading edge of the active phase is. So it's somewhere in the Atlantic Ocean right now. Per both models, we'll look at the ECMF model first. If the dot is good distance away from the circle, it's stronger. Closer, it's weaker. So we'll say a weak leading edge of the active phase in the Atlantic Ocean. Forecast to build a little and continue, just follow the green line here, back to the maritime continent 2 weeks out. The GEFS model basically says the same thing, maybe a little bit weaker, not as pronounced, but generally the same thing, so the models are in sync. The 40-day upper level model, so same sort of deal. The greens are areas favorable for precipitation, so one would assume the active phase of the MJO. Now it's interesting because remember, outgoing long wave radiation on one of those previous models showed it all over here, and we thought the active phase was here. This says it's over here. The reality is its center is probably somewhere sitting right around in here. Either way, the net effect is, and this is sort of runs almost a week ahead of what you see down at the surface. So the yellows and oranges are areas not favorable for precipitation, so this suggests the leading edge of the inactive phase of the MJO is to be pushing. Oh yeah, there's the Philippines, there's New Guinea, there's the equator, South America, so that's the path we're looking at. Inactive phase of the MJO moving into the Pacific and finally moving out of the Pacific December 22nd with the active phase of the MJO starting to develop in the West Pacific. We'll say December 17th, but we know this runs about a week ahead. So December 25th is when the Pacific will wake up again. Our thoughts is, yeah, we'll get about another week out of this active phase of the MJO. Then this inactive phase will set up, let's say December 9th, and be affecting us till about Christmas. And then about Christmas, things should wake up in the Pacific, and the active phase makes its trek across the Pacific into January 11th, and then the inactive phase shows up again in the West Pacific. So the cycle on and off, about 3 to 4 weeks on each phase of the MJO cycle. Now the CFS model paints a little bit better a little bit different and we'll say better picture, okay? Because it just isn't about the MJO. The MJO is just one component. El Nino, or some flavor of an El Nino-like pattern, is yet another component. So here we are today. This is, again, the whole planet on one chart. The main area, Kelvin wave generation area, let's say 135 east to 170 west, right in between these two tick marks. Here we are today. This is past performance. You can see, and these reds are westerly anomalies. You can just see it's been nonstop westerly anomalies in the Kelvin wave generation area since September 8th. So there's been lots of latent potential in the atmosphere and in the ocean to support storm development. This active phase, this heavy black line here, is what's been driving our latest storm cycle. But notice, look at this. From December 1st to the end of December, westerly anomalies are to continue in the Kelvin wave generation area. So that means that, yes, we might go out of the active phase of the MJO into the inactive phase, but that doesn't mean that the potential for storm development is going to disappear. When you get this sort of a pattern, you know, and this is what El Nino is all about. This is what El Nino looks like. We may not be in an El Nino right now, but it sure looks like it is, and the atmosphere, we think, is going to respond accordingly. That is, the storm track might still continue to be productive even in the inactive phase of the MJO. And then here's the 3-month CFS model. Okay, so same deal. Kelvin wave generation area basically between these two tick marks, but past performance is on the bottom. The forecast is going forward. You all have been through this before. You can see the preponderance. These yellows and oranges are westerly wind anomalies. Preponderance of westerly wind anomalies in the Kelvin wave generation area, and for that matter, across large swaths of the Pacific since August. Here we are today. Yes, and let's overlay the MJO. There you go. The heavy red contour is the active phase of the MJO. It is moving to the east, fading out by about December 7th or so. It should be gone. So another 5 days, and then it's over. You see the light contour? This is the inactive phase of the MJO, but notice the yellows here. Westerly anomalies continuing even through the inactive phase of the MJO. Another weak active phase sets up December 18th. Okay, that's even better. We were saying December 25th, we thought, from those other charts. So December 18th, that's good. And continuing the whole way into late in January with strong westerly winds forecast. That'd be a westerly wind burst. If there was ever a time for storm development, it would be in this window, the month of the end of December through the end of January. Then maybe things back off, weak inactive phase of the MJO. Another active phase after that. All right, let's overlay the low pass filter, and that really tells you what's going on. This is the solid contours are a bias towards low pressure, and you can just see they're locked in right over the date line. This is over the past couple of months, and are continued to forecast, if anything. Now, this is interesting. I just noticed this. They kind of retrograde back to the west as we get into February. This is most interesting. Typically, you would see them fading, working their way off to the east. Also notice the dotted contour here. This is high pressure bias at 90 east. That's basically over the core of the Indian Ocean. This is your typical El Nino kind of setup. Now, we're not saying that we're in El Nino, but the atmosphere thinks that we're in a El Nino-like environment. So it doesn't take a whole lot to get storms going when you have a low pressure bias over the dateline. You have and that's what's driving perpetual westerly winds over the dateline region, the Kelvin wave generation area. Then all it takes is this weak little active phase to really set things going. And just like what we're having now, I mean, no, last winter we couldn't get a storm to save our life. This winter we've already had, we're already in our storm number 2 with 50-foot seas, or storm number 1 had 49-foot seas, but you get the picture. Things very active, a lot of energy in the atmosphere. It's all attributable to this low pressure bias and these westerly anomalies hanging on the dateline, and the expectation is that's going to continue the whole way through the winter. All right, so let's dig deeper. No more talk about the MJO, though. We're through with that. You get the general picture. Let's talk about El Nino or whatever is happening. All right? Subsurface temperatures, West Pacific here, East Pacific here. These are the anchor lines on the TAO buoy array, a series of buoys strung across the equator, used to monitor El Nino. The X's are the sensors on the anchor lines. From those you can get temperature profile, and then you can use a model to sort of string it all together to fill in the gaps. 30-degree anomalies, so they used to be broader, filling even last week almost out to the date line, back to 172 east. This means that the super warm, this is 30 degrees centigrade, so certainly warmer if it was Fahrenheit. Gives you the sense that warm water is dissipating a little in the East Pacific. The 28-degree isotherm line holding steady at 153 west. This is where it was last week. And the 24-degree isotherm pushing into Ecuador. So basically, no change in temperatures. But let's go look at anomalies, differences from normal for this time of year. So you clearly see here a pattern of warm water from the West Pacific the whole way to the East Pacific. Last winter, it was cold water over here. That's the hallmark of La Nina. Now you go, well, this warm water must be El Nino. Well, it takes more than that to get you El Nino. But anyway, so we talk about the Kelvin wave generation area, right? From 135 east to 170 west, right in this area. When you get westerly winds here, that takes this warm water that's here and starts pushing it to depth, and it starts traveling off to the east. When you get a ball of warm water like that, that's a Kelvin wave. This is the second Kelvin wave of this supposed El Nino cycle. It's pushing into Ecuador now. It's erupting on the ocean surface, getting caught by the trades, and then starts pushing back to the west on the equator. Now we got this other individual pocket of 3 degrees anomaly, which we had kind of thought just kind of blown it off. But, you know, there's been so much westerly anomalies going on. We think it is maybe the beginning of Kelvin wave number 3 developing. It's been this 3-degree ball has been hanging here for a couple of weeks, and we kind of just wrote it off as anomaly, but it actually appears to be getting bigger. And that's actually a good thing. And we'll dig a little deeper. So Kelvin wave number 2 pushing into Ecuador, possibly Kelvin wave number 3 developing under the date line. Another version of that same data, you can see very warm temperatures in the East Pacific here. 1, 2, 3, 4, 5, 6 shades. 1, 2, 3, 4, 5, 6. Pockets of 5-degree centigrade anomalies. That's quite warm. Pushing into Ecuador, out back to about 135 west, so about halfway between California and Hawaii, let's say. So that's probably another maybe a month's worth of warm water still to erupt to the surface here. That's good. And then here we see this is really, you go, well, what's that? That's not much. Well, what we were seeing over here was cool anomalies like that a couple of weeks ago. That's gone. Building warming here. Here is that pocket of 3 degree. What was this? 1, 2, 3, 4. 1, 2, 3, 4. Yep, 3-degree anomalies at 170 west. We think this is the start right here of Kelvin wave number 3. That'd be good. And you also see here the warm water from Kelvin wave number 2, the whole way up to the surface, the whole way out to the date line. So this is what fuels El Nino. Warm water, the westerly winds, the westerly anomalies create a Kelvin wave. It moves east. It erupts on the ocean surface, gets caught by the trades, pushes back to the east on the equator, and starts filling the equatorial Pacific with warm water. If you have I think it's 5 consecutive months of temperatures above half a degree above normal, then you're officially in El Nino. Well, we're not there yet, but we'll get into this a little bit more. Just keep that in the back of your mind. Sea level anomalies, another way of measuring, and it's just the equator that we're worried about. Warm water on the equator. So if you strip out, so this is JSON2 data. If you strip out all the waves, strip out the tides, strip out wind waves, and you just measure the height of the ocean surface as compared to normal, what we're seeing is this giant pool of 5-centimeter anomalies. 5 centimeters, that's not much. But what this means is if you have warm water at depth, warm water expands, it creates a little bulge on the ocean surface. What we're seeing is warm water the whole way across the equator. And you can actually see it squeezing out from the maritime continent. There's New Guinea right there. Tracking north of New Guinea, then it falls to the depths, and this is where it starts building into a Kelvin wave. So that would be possibly Kelvin wave number 3 right out here, Kelvin wave number 2 right here erupting on the, along the coast, and then a linkage between the two of them. Just a huge thousands of miles of warm water pushing east. That is a good sign. Upper ocean heat anomalies, the upper 300 meters of the ocean's surface, temperatures. Remember last year we talked about December 2017, cool water in the East Pacific, there it was, that was La Nina, and look at the difference between there and where we are this year in December. Much warmer, and here's that warming the whole way across the Pacific, but this puts it in time frame, so you can actually see the Kelvin waves. A little baby Kelvin wave in January tried to make it east, it failed, but then here was Kelvin wave number 1 in February. Warm water pushing east, sort of stalled, and then it finally moved onshore in the July time frame. Upwelling phase of the Kelvin wave cycle, things cool off a little bit. Here was Kelvin wave number 2, and you can see it pushing, developed from a westerly wind burst in the western Pacific in the September time frame, traveled the whole way across the Pacific, is erupting along the coast now, and we think there's our upwelling phase of the Kelvin wave cycle. That just happened, and you can't even see it on the chart, but we have the sneaking suspicion that somewhere right in here, Kelvin wave number 3 might be starting to develop. All right, so westerly winds are great and cool, and subsurface temperatures are, you know, wonderful to understand, but at the end of the day, it's what's going on the surface that really matters, because it's the ocean surface. If it's warm, then it starts really feeding the jet stream, especially if it's warm out over here. Westerly winds and all that, they'll feed the jet stream, they'll do a lot, but you start getting this feedback loop if you get warm water over here, and that also starts feeding the jet stream. This is from the ocean, and then if the atmosphere starts really driving, that yet feeds the, starts pushing more westerly winds, and then the atmosphere and the ocean start working together, and that's when they're quote-unquote coupled, all right? So the part of the discussion here now is about, are we in El Nino? And if we are, is everything coupled? Or if it's not, why isn't it coupled? Okay, so right now, clearly, warmer, you can see this is sea surface temperature anomalies. The reds are warmer than normal water temperatures. But if you notice here, they're not as warm as they were last week when we looked at this. Still, they're warm, very respectable, and covering the whole way from Ecuador, the whole way out to the date line, okay? 5 degrees north, so the official El Nino monitoring region is out here, 120 west, 5 degrees north and south to 160 west. Draw a box right there. Clearly, warmer than normal temperatures there. We know that Kelvin wave number 2 is erupting in this area. You can see that clearly, but not as strong as, one might expect, and not as strong as previous days. Also notice warming all under Mexico, but a big pocket of cool right here. Not super cold, but just cool, sort of hanging on, not sort of the, I'll even say the hangover of La Nina, if you want to say it that. Now, we do have warming along Peru, that's good, and Chile, that's good, but if it was a really significant El Nino, you'd have like a triangle of warming that would look like this, and we don't have that. We have this sort of ill-formed, generic, yes, there's warming where it needs to be, but just not, there's not a significant atmospheric reinforcing response here. This looks like it's all just being driven by what's going on in the ocean and westerly winds in the far west Pacific, but it hasn't really like set up a change in the winds the whole way across the Pacific yet. More about that in a minute. What has the trend been for the past 7 days? Well, where you see oranges and yellows, that's where things are getting warmer, and it's getting warmer in all the right places. Warmer here along the equator from Ecuador the whole way out to the date line. Warmer along Peru and Chile, all looking good. Pretty much steady state, maybe slightly cooler along California, but the area that really matters is right along in here. Not a bad picture. Let's zoom out. And here's the overview picture. Warming the whole way across the equatorial Pacific, and yes, up into Mexico in that area, but cooling right here. Just kind of, that's the fly in the ointment, if you will. It just doesn't quite look like El Nino. Let's go take a look at water temperatures. Here is water temperatures in the Nino 1.2 region. Basically the area off of around the Galapagos, Ecuador, Peru, that area. And the trend, if you draw a line through that, definitely upward. Down a little bit today at 0.925 a degree. So there's 1 degree. So basically we're we're about 1 degree above normal. And it doesn't take much to get you an El Nino, but this isn't the official area. This is just sort of where you can see the effects of the Kelvin wave erupting in the Galapagos, and that's a good sign. And this is the official El Nino monitoring region, the Nino 3.4, from 120 west out to 170 west, 5 degrees north and south of the equator. You see the same thing going on. Temperatures steadily warming today at 0.850. So the models were suggesting by December 1st we should be about 1 degree. We're not there. And we were actually the models were saying we were supposed to be much warmer than what we are. And so it's like, why are the models thinking we're supposed to be warm, and why are we not as warm? So let's dig into this bit about coupling of the ocean and the atmosphere. So we look at the Southern Oscillation Index, the difference in pressure between Tahiti, which is in the Pacific, and Darwin, Australia, which is in the Indian Ocean. When Tahiti has lower pressure, that means that there's basically, remember that low pressure bias we said over the date line? Then that means that low pressure is in the Pacific, and the Southern Oscillation Index is negative, and that's like El Nino. When you have low pressure over Darwin and high pressure over Tahiti, that's La Nina. All right, so what's the daily contribution? It should be negative if we're in El Nino. Well, it's not. It's plus 13.86. Let's just go, oh, maybe that's an anomaly. Let's go back and look. Yeah, there's some negatives, but it's been positive pretty much for a while now. The 30-day average, okay, so let's just sort of take all the noise and look at it. 0.95. So we're still positive. We're not even negative for the 30-day average. If we were in El Nino, this should be down at minus 15. And normally El Nino peaks around December 25th. There's no way you're getting from 0.95 to minus 15 in the next 25 days. It just isn't happening, right? The 90-day average, take even more noise out of it. And this gives you a real indicator of El Nino. Okay, minus 1.74. But look at this. Going back 30 days, we were at minus 3.8 in November. We've actually lost ground. So can you call this El Nino? Not even close right now. It looks like the ocean wants to be an El Nino, but the atmosphere sees no signs of it. This is all, remember, this is all about pressure. This has nothing to do with ocean temperatures or anything. This is what's happening in the air above the ocean. The ocean looks like El Nino. It looks like it's trying. The atmosphere is going, I don't see it. There's no significant warming here. You know, if you get a lot of warming on the equator, you're going to start getting more evaporation. The more evaporation you get, you're going to get precipitation. And that's sort of, especially over by the Galapagos and all that, that's the hallmark of El Nino. We're not seeing any of it per this index. Let's go look at the SPI. So here's the SPI index. It hasn't updated since November 27th, and it was locked then at minus 0.02, and it doesn't change a whole lot. So what this is about is if you, instead of measuring pressure in the area north of Darwin, Australia, and north of Tahiti, you measure rainfall amounts, okay? If you have more rainfall over here, the index goes positive. Well, it's negative, meaning precipitation is pretty much normal, neutral. And that's kind of what the Southern Oscillation Index is saying. Precipitation here is normal, nothing different than normal. If we were in El Nino, this guy should be up at plus, 1 or 2 or something like that, or maybe even more, and it isn't. So all this says is that the ocean and the atmosphere are not coupled. They haven't been coupled. And we don't think they're going to be coupled anytime soon, because if they were going to be coupled, it should have happened by now, and it hasn't. That's not a bad thing, okay? Let's be clear. If you get an El Nino, the very next year after you have your El Nino, you're back into La Nina. That's just kind of the way the game goes. Sometimes, though, you get these weak El Nino-like patterns that go on for 2 or 3 years, and that actually is better for surf. The jet stream picks up on it. It takes a while. It's this long-lasting, steady, just push in the atmosphere, and for years it just pumps. Or, you just go, it's amazing. And then, just like what we went through the past 2 years where it was just horrible, well, I think that's where we're moving here, is not into an El Nino pattern, but into this sort of not El Nino, but just this warm pattern that goes on and on. So some people then start asking about the PDO. Okay, so we'll do this real quick. So without getting into all the details here too much, we're just going to show you. So this is the PDO index, and the PDO is sort of like a long-running El Nino, La Nina thing, like 20 years on, 20 years off kind of thing. You can see in starting in, so here, all this is, we call it the warm phase. The reds is when the ocean is just sort of like in a long-running El Nino kind of pattern. It started in like January 75, and you see it went the whole way. Yes, there are down phases in it, but it was very clearly indicated up to the big El Nino of 1997, and then all of a sudden the bottom fell out and the trend turned cold. And if you'd been surfing prior to this time and was really dialed into the weather, you remember things were just unbelievable. It didn't, you know, the ocean didn't stop. And then in 97, the bottom kind of fell out. Yes, we had lots of surf. There were swells, but over time, they got less and less and less until we hit, we think, this is the guess, starting January 2014, there was a big El Nino, a super El Nino, right? A lot of hype. Really didn't materialize the first year. It was really the second year, like 2015, 2016. And then you see things have died off a little bit, but the negative side of it is not so negative. The thought is maybe we've transitioned after a, let's see, from 97 to 2014. So what is that? About 17 years. Maybe that was a short-lived cool cycle, and we're now moving into a warm cycle. But as of right now, I mean, just, you know, the real kind of data suggests right now it's hard to tell. It looks like we were warm, but in the past year or two, we've been cool, but not real cool, thinking that we've turned the corner, and maybe some of what's going on this year is the setup for a beginning of one of these sort of cycles where it's warm and it just goes and goes. You're not in El Nino, but you're in this warm thing, and it just pushes and pushes. So we're thinking that's where we are. All right, so just to wrap up, we've gone on way too long here. The forecast for the Nino 3.4 region, the official El Nino monitoring region. We were saying here we are in December. Temperatures should be 1.1 degrees above normal. They're barely at 0.85, and the average is probably somewhere down here around 0.6 or something like that. Forecast says continued warming, full El Nino mode through April. But notice, look at this. Even if this is off by half a degree or more, notice it says July, August, temperatures still at 1 degree above normal. Sort of hints at, well, maybe the model doesn't have it right, not even close, but we are warm. But it also hints at it isn't going to get cold anytime soon either, which then leads us to the discussion of, well, has the PDO changed? And also, are we into one of these multi-year weak El Nino kind of things? So the hope is we are. That would certainly be the end of droughts. That would certainly be the end of, or the beginning of a long run of surf, not only in the winter, but in the summer relative to California and Hawaii. So way too early to know. Tantalizing tidbits hanging out there in the future. We're just going to have to keep monitoring and seeing. But for now, the good news is another storm in the water, swell on the way, and more behind that, and rain, and it's like, hey, maybe the drought's over and we're back into the good times. This is good news. You know how it goes. So for now, bird in the hand, right? Take what you can get. There's swell in the water. Make the most of it. And we'll do this again next week. Same time, same channel. Thanks for watching.